Now, yesterday we discussed the probability, which is the basic thing of the statistical mechanics, and today we will discuss some terminology, basic terminology of the statistical mechanics. So let us start with the phase space. So the first topic is phase space. In general, if we want to locate any particle, then we need three Cartesian coordinates, to represent any particle, the position of any particle. To locate any particle. And these three Cartesian coordinates are x1, x2 and x3, or we can say x, y and z. But in statistical mechanics, we represent any particle by the six coordinates, and these six coordinates are three Cartesian coordinates means three positions, and three momentum coordinates. So three Cartesian coordinate means again it is the x, y and z, and three momentum coordinates means it will be px, py and pz. So now we have the six-dimensional space. So in six-dimensional space, we represent the particle by six coordinates, which is the x, y, z, px, py, pz. So suppose we have a system of n particles. And therefore in total we will have the 6n dimensional space. Now we can represent all these n particles in two ways. Either we take the six-dimensional space, and then in that space we will put n phase points corresponding to each particle. So for clarity, I am giving you the example of the two-dimensional space. Suppose this is the x-axis and this is the y-axis, and if we have the 10 particles, then what we will do, for each particle we will locate that particle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this two-dimensional space we have 10 points, or we can say these are the 10 phase points. We have the 10 phase points. And now In the same way, if we have the 6-dimensional space, that is the xyz and then px, py, pz, and in the system we have the n particles, so we can locate those n particles in the 6-dimensional space as the n phase points. So we will have the n phase points for that system at an instant, for the system at any instant, at any instant. So why I am saying at any instant? Because at particular time, but at the time will change, these positions will also change. Suppose these are 10 particles and these 10 particles are moving. So at a particular instant, at a particular time, the position is denoted by all these 10 points, but as the time will change, then this position will also change. So I am writing here कि in 6-dimensional space we can locate n phase points for the whole system containing n particles at any instant. So this is the one way, this is the first way. And in the second method, we can take the 6-dimensional space, 6n dimensional space. In the second method, we can take the 6n dimensional space. So what is the meaning of 6n dimensional space? It means we will have the x1, x2, x2, x3 up to xn. Then we will have the y1, y2, y3 and so on. y3 up to yn, and then we have the z1, z2, z3 up to zn. So these are the position coordinates, and in the same way we have the momentum coordinates. So px1, then px2, and then px3 up to pxn, and then we have the py1, py2, and then py3 and py3 and then py4, and this is up to pyn. And in the same way we have the pz1 and then pz2, pz3, and this is up to pzn. So in total these are the 6n dimensional space, and we have a system containing n particles. We have a system containing n particles, containing n particles. So if we represent a system containing n particles in 6-dimensional space, then we will have only one phase point. We will have in the 6-dimensional space only one phase point. Why only one phase point? Because we have already denoted the 6n dimensional space. In the first representation, we have denoted the 6-dimensional space. We have considered the 6-dimensional space, and therefore we have to put n points, n phase points. But here we have considered the 6n dimensional space. Therefore, for the whole system containing n particle at any instant, we will have only one phase point. So this is known as the, if we represent such a 6-dimensional space, then that is known as the mu space. Mu space or the mu phase space. All these are known as the phase space, means the combined space for the position and momentum coordinate, that is known as the phase space. So you can define the phase space as the combined space of position and momentum, of position and momentum. So that is known as the phase space. And if we represent the phase space in the by the 6-dimensional space, then that is known as the mu space. That is the mu space. And in the mu space, for a system containing n particles, we will have the n phase points at any instant of the time. But if we take the 6-dimensional space, then that space is known as the tau space. This is termed as the tau space. or this is also known as the gamma space. Tau space or gamma space, or this is more accurately tau phase space or the gamma phase space. So both are the phase space, either it is the mu space or it is the tau space or it is the gamma phase space, are all known as the phase space, denoting the particles or denoting the system in terms of the position and the momentum. And if it is the mu space, then we will have the n phase points, and if it is the 6 n dimensional space, then we have only a single phase point for the whole system at any instant. And as the time will change, then this phase point will also move, because now for another time it will have another value of the position and the momentum. So this is all about the phase space. Then we can have the smallest cell. We can denote a small cell in the phase space. A small cell or a small element in phase space. In phase space. And that is represented as dpx, dpy, then dpz, and then dx, dy, and dz. So this is small element denoted by dx, dy, dz, dpx, dpy, dpz represents a cell or an element in the phase space. This is the smallest cell or the smallest element in the phase space. So now come to another topic, which is the microstate and macrostate. So put another heading. This is the microstate and macrostates and macrostates. Now, if we analyze the phase space with a deeper insight, means deeper analysis of the phase space, then we call it as microstates. And if we do the superficial analysis of phase space, then we call it as macrostate. So microstate is something which is smaller. This is smaller. And macrostate is something which is larger. This is larger. So suppose in a phase space we have a system containing, let us say 10 particles, and we want to distribute these 10 particles into 3 cells. Distribution of 10 particles into 3 cells as 2, 3 and 5. Means in one cell we will have the 2 particles, in another cell we will have the 3 particles, and in another cell we have the 5 particles, 2, 3, 5. And let us say the particles are A1, A2, A3, A4, A5, A6, A7, A8, A9 and A10. So these are the particles A1 to A10, and we have to distribute into 3 cells. So what we can do, we can have a distribution like this. In the first cell it is A1, A2, and in the second cell, because there are 3, so A3, A4, A5, and in the fifth cell or in the third cell we have the 5 particles. So 5, A6, A7, A8, A9 and A10. So this is the containing 2 particles, this has 3 particles, this has 5 particles. So these are termed as the macrostates. Macrostates means number of particles in the cell. Number of particles in the cell. In the cell. It has nothing to do with which particle. Macrostates define only the number of particles of the cell. So this is a particular macrostate. This is the particular macrostate in which there are 2 particles. Now when we come to the microstates, then it defines which particles in the cell. So this is the one type of the distribution in which we have 2, 3, 5 and A1, A2 and like this. Now we may have the another distribution. And another distribution, let us say A3, A4 in the first cell, and then A5, A6, A1, omit this A6, A1, A2 and A5 in the second cell, and then the remaining means again it is A6, A7 up to A10. So this is another type of the distribution in which we have, instead of A1, A2 in the first cell, now we have the A3, A4 in the first cell. So the macrostate will remain the same, because how we define the macrostates? We define the macrostates as the number of particles in the cell. So in this particular macrostate, there are 2 particles. It doesn't have any effect that these particles are A1, A2 or A3, A4. If the particles are A1, A2, then the macrostate will remain same, and if the particles are A3, A4, then the macrostate will remain same. But the microstate will change. Macrostate will change because now we have, instead of A1, A2, now we have the A3, A4. So now you can understand this clearly, that macrostate means the number of particles in the cell, and microstates means the which particles in which cell. And then we can have, in a given microstate, we can maintain order also. Here I have written A1, A2. One can also write it as A2, A1. But this has no effect. If we change the order in the microstate, then it has no effect. So A1, A2 and A2, A1 will define the same microstates. The only thing is that which particles, the order doesn't matter. So this is about the microstates and the macrostates. And let us note one more line in your notebook, that a given macrostate may have different or may have many microstates. So in this example you can see this, because our macrostate is the 2 particles in a cell. That defines our one particular macrostate, 2 particles in a cell. But this particular macrostates have A1, A2 a different microstate, then A3, A4 a different microstate. In the same manner we can have many microstates, A3, A4 or A5, A6. There may be many combinations. Therefore a given macrostates may have many microstates. So this you can note down. Now come to the another topic. Now we will take one example of this, macrostates and microstates. One more example, macrostates and microstates. And I am taking the same example, that is we have the 4 different coins. We have 4 different coins, and if we toss it and we get head, then it is termed as A, and if we get B, a tail, then this is termed as tail. So how many combinations are possible for these 4 different coins? We have done this exercise for the 3 coins. Now I am writing for the 4 coins, and then you can understand more clearly what is the meaning of the macrostates and the microstates. So let us write all these combinations. So these are the 4 head, A1, A2, A3, A4, and then we have the 2 head. So A1, A2 and B3, B4, and then A1, B2, A3, B4, 2 head. Here it is 4 head, now it is 2 head. Then A1, B2, B3 and A4. Then it will be B1, A2, A3 and B4. And another it will be A2 and A4, and then B1 and B3. In another combination it will be B1, B2 and then A3 and A4. 1, 2, 3, 4, 5, 6. Yes. Then let us write for the 3 head. 3 head means A1, A2, A3 and B4. B4, and then here it is B3 and here it is B2 and then B1. So now it will be A1, A2 and then A4, and here it is A1, B2, A3 and A4, and here it is B1, A2, A3 and A4. So this is 1, this number is 1, and then 2 head means 1, 2, 3, 4, 5, 6, up to 6. So this is 6, and then this is 4, 3 head, and then we have 1 head, only 1 head. So A1, A2, A3 and A4, and then fill this. So it will be B2, B3, B4, and here it will be B1 and then B3 and B4, and again it will be B1, B2 and B4, and it is B1, B2, B3, and these are again the 4, and then last is the all tail. So it is B1, B2, B3 and B4. This is 1. This is 1. So this set, that is we get 2 head and 2 tail. So that will give 1 macrostates. All these 1, 1, 6, 4, 4. These are the macrostates. So we have the 5 macrostates. We have the 5 macrostates. But within this macrostates, a particular macrostate which is defined as macrostate, which is defined as 2 head and 2 tail. So this is a particular macrostate which is defined by 2 head and 2 tail. So what will be the number of microstates? Now any can tell this? अपना mic खोल के बताइए, कोई बताइए. Number of microstates corresponding to this macrostate. ये जो macrostate है इसके corresponding बताइए. What will be the number of the microstates? जहाँ पे 2 हेड और 2 टेल हो, ऐसे कितने कॉम्बिनेशन है? हाँ बताओ भाई, कोई बताओ। ये तो बहुत ही सिंपल है। हैं? टू हेड एंड टू टेल। इसमें देखिए ये जो हमने बनाया हुआ है, इसमें देखिए कितने ऐसे कॉम्बिनेशन हैं जिसमें, हाँ नहीं, टू हेड एंड टू टेल। नहीं, फोर कैसे हुआ? सिक्स हुआ ना, ये देखिए ये है ना, ये वाला। नहीं नहीं, ये वाला है ना, A1 A2, A1 A2, और ये वाले जो कॉम्बिनेशन है, ये जो कॉम्बिनेशन है, इस कॉम्बिनेशन में देखिए देयर आर टू हेड्स एंड टू टेल्स, लेकिन किस में है ये फर्क नहीं पड़ता है ना, केवल। तो दैट इज दी सिक्स, आंसर इज सिक्स, करेक्ट आंसर इज सिक्स। सिक्स हुआ है ना, टू हेड एंड टू टेल इज द सिक्स, एंड देन नंबर ऑफ माइक्रोस्टेट्स इज सिक्स, लेकिन ये जितने भी हैं ये डिफरेंट माइक्रोस्टेट्स हैं। सो एज आई said a line that a particular macrostates may have many microstates. So this situation defines this, that this is a particular macrostate and this particular macrostate has the six microstates. So this macrostate has six microstates. तो ये अब आपको शायद थोड़ा समझ में आ गया होगा कि what is the macrostate and what is the microstate. Now tell me, what is the total number of macrostates? Total number of macrostates in this example. हाँ बताइए, टोटल नंबर ऑफ मैक्रोस्टेट मतलब कितने इसके ग्रुप बन रहे हैं, उस हिसाब से बताइए। द टोटल इवेंट्स आर 16. सो व्हाट आर द टोटल नंबर ऑफ मैक्रोस्टेट्स? हाँ गलत सही कुछ भी बताइए, कुछ लोग माइक खोलिए अपना, बताइए। हाँ यस, इट इज 5. 5 because we have the 5 groups, 1 2 3 4 5. We have 5 varieties and therefore the number of macrostate is 5, and for this particular we have only one microstates. For this particular we have only one microstates, and here it is only one microstates, and here it is the 6 microstates, here it is the 4 microstate, and here it is the 4 microstates. So what is the total number of microstates in this example? Not corresponding to a particular macrostate, but the total number of microstates. Yes, good. It is 16. So total number of macrostates is 5 and total number of microstates is 16. And now if we want to calculate the most probable macrostate. So which is the most probable macrostate? जिसमें सबसे ज़्यादा माइक्रोस्टेट होंगे वो मोस्ट प्रोबेबल होगा. सो विच इज़ द मोस्ट प्रोबेबल? यस, 2 head plus 2 tail, and the probability is, now tell me what will be the probability of this? Probability is defined as the number of the events divided by the total number of events. Three by 8. Yes, it is 6 by 16. 6 by 16, and therefore it will be cancelled by 2 and it will be 3 by 8. 6 by 16 and then it will be 3 by 8. So this is the most probable macrostate. And which is the least probable macrostate? Least probable macrostate. Least probable, either forehead or foretail. And what will be the probability of forehead? 1 by 16. So it is 1 by 16 for the forehead and 1 by 16 for the foretail. So this is all about the macrostates and the microstates. Now come to another topic. That is the thermodynamic probability. So yesterday we discussed the simple probability. Now we are discussing the thermodynamic probability. Thermodynamic probability. Now you can note down this. Thermodynamic probability is defined as the number of microstates in a given macrostate. It is defined as number of microstates in a given macrostate. So suppose we have a system of n particles. And we want to distribute these n particles, distribution of these n particles into cells containing n1, n2, n3, n4 particles. Means we have the four cell. And in one cell there are n1 particles, in another it is n2 particles, in another it is n3 particles, in the fourth cell n4 number of the particles. So what is the constraint or the equation? Equation is n1 plus n2 plus n3 plus n4. That should be equal to capital N. Because we have divided or we have distributed the n particles into four cells with the number n1, n2, n3, n4. Then the total number of the permutations for n particles is equal to n factorial. But this n factorial also includes the order of particles inside the cell. It means that either we have written the particle as A, B, C, D, or we have written it like A, C, B, D, or we have written it like D, B, A, C, and there may be more combination. But this is a particular macrostate in which there are four number of the particles. So this represents a one cell containing, let us say n1 is equal to 4. If n1 is equal to 4, it means we have the four particles. But if we write it as A, B, C, D, A, C, B, D, then it will represent the same microstates because order doesn't matter. So for a 4 particle, the number of the permutation the number of permutations for n1 particles inside the cell that is also defined by n1 factorial. So this n1 factorial, n2 factorial are has no meaning, but it is representing only the order inside the microstate, and therefore we will not count this n1 factorial, n2 factorial, because they will represent the order. So now how we will define the thermodynamic probability, which is represented as the omega. This is represented as the omega, or sometimes it is also represented like this. ये दोनों सिंबल यूज होते हैं. So the thermodynamic probability omega is equal to n factorial and then divided by, we will exclude these n1 factorial, n2 factorial, n3 factorial and n4 factorial, because these n1 factorial, n2 factorial, n3 factorial and n4 factorial, these numbers represent only the order inside the microstate, and while we define the microstate, the order doesn't matter. Therefore the n factorial will be divided by all these numbers, because n factorial includes all these ordering also. Therefore the probability is represented by n factorial, where n is the total number of the particles in the system, and divided by n1 factorial, n2 factorial and so on, where n1, n2, n3 are the number of these are the number of the particles in a given cell. So this is about the thermodynamic probability. Now we will take one more example of the thermodynamic probability. Now suppose we have only 4 molecules. So example. ये सारांश ये दरवाजा बंद करो जरा मेरा. So now let us take an example. And in this example we have the 4 molecules, are the 4 particles, and we have to divide in 2 cells. So suppose one cell is the I, another cell is the J, and these particles are, let us say A, B, C, D. So what we can do, in the first we have to divide in 2 cells. So here it may be 0 and here it is the 4 particles, and then we have 1 particles and the 3 particles, then we have the 2 and 2 particles, then we have the 3 and 1 particles, and then 4 and 0 particles. So these are the distribution, and all 1, 2, 3, 4, 5, all these represent the 5 macrostates. 5 macrostates. And now we take a particular macrostate. Let us take a particular macrostate, and that particular macrostate as defined as 1 and 3 distribution. That is, in the first cell it is the 1 particle, in the second cell it is the third particle. So now we will go into deep. Which particle will be in the I cell, and the particular macrostate means in the I we have the 1 particle, in the J cell we have the 3 particles. So how we will distribute these 4 particles A, B, C, D here? So here it may be A, and if A, then here it will be B, C, D, and then we have the particle B. So here it will be A, C, D. Then we have the particle C. So here we have A, B, D, and then we have the particle D, and therefore in the J cell we have A, B, C. So what are the number of microstates now? Corresponding to this macrostate, what is the number of microstates? Number of microstates. हाँ बताइए कितने माइक्रोस्टेट्स हुए? Open your mic. Number of microstates corresponding to this. हाँ कोई बताओ भाई, आसान है ये तो. 8 कैसे हुआ? नहीं, टोटल नंबर ऑफ माइक्रोस्टेट्स नहीं पूछ रहे हैं. द नंबर ऑफ माइक्रोस्टेट्स करस्पॉन्डिंग टू दिस मैक्रोस्टेट. This macrostate in which the one particle in the ith cell and 3 particles in the jth cell. ये तो मैंने बिल्कुल बना दिया इसे. आंसर तो बिल्कुल आपके सामने लिखा हुआ है. 4. There are 4 ways in which we can distribute these 4 molecules or 4 particles into the 2 cell 1 and 3. So the thermodynamic probability is here 4. Thermodynamic probability is 4. Now we can calculate the thermodynamic probability in a different manner with the formula also. So let us calculate with the formula. According to previous formula, what should be? N factorial divided by N1 factorial and N2 factorial. So this is the formula. So what will be the value of capital N here? इसको कैलकुलेट करके बताइए. आप इस फॉर्मूला से कैलकुलेट करके बताइए. यहाँ से तो बिल्कुल क्लियर है. फ्रॉम दिस डिस्कशन इट इज क्लियर दैट द नंबर ऑफ माइक्रोस्टेट इज 4. देयरफॉर द थर्मोडायनेमिक प्रोबेबिलिटी विल बी 4. And from here we can calculate it as 4 factorial because the total number of the particles are 4. And then n1, n2, n1 is 1 factorial and n2 is 3 factorial. क्योंकि जो हमारा डिस्ट्रीब्यूशन है that is 1 and 3 in the 2 cell. So 1 factorial and 3 factorial. So it is 4 into 3 factorial divided by 1 factorial means 1 and into 3 factorial. So this get cancelled and we have the 4. तो अगर हम इस तरह से कैलकुलेट करें नंबर ऑफ माइक्रोस्टेट्स निकाल के तो भी 4 ही आएगा, और अगर हम इस फॉर्मूले से कैलकुलेट करें तो भी 4 ही आएगा. बट वी कैन नॉट कैलकुलेट इन दिस वे for all the examples because here the number is only 4, but if we take the number 100 then we cannot write such type of distribution. It will take many pages and many time. So then in that case we have to calculate the thermodynamic probability using this formula. So this is about the thermodynamic probability. Now using this thermodynamic probability we have an important equation or important formula. That formula is known as the stirling formula. So let us do that also. Stirling formula. Stirling formula. So most of the time we will need to calculate the log of the thermodynamic probability in many further discussion. So we have the thermodynamic probability as omega is equal to n factorial and then n1 factorial, then n2 factorial and n3 factorial. So let us stop here, n3 factorial. And if we take the log of both sides, then log omega is equal to log of n factorial minus log of n1 factorial, then minus log of n2 factorial minus log of n3 factorial. So how we will write this? The formula for log n factorial, and this is the Stirling formula, that log n factorial is equal to n log n minus n. So this is the Stirling formula, that is log of n factorial is equal to n log n minus n. So in this way we can write all these factors, minus, then n1 log n1 minus n1, and then minus n2 log n2 minus n2, and so on. Now if we want to calculate the maximum probable condition, the condition for the maximum probability or most probable probability, most probable condition. So what we have to do for the most probable condition, we have to calculate the delta of the log omega, delta of log omega, and we will put that log omega is equal to 0, and from there we will get the most probable probability. So if we do this, if we calculate the delta of log omega, so what will be this? Delta of log omega. So on the other side it will be delta of n log n, and that will be 0. Delta of n is also 0. Why? Because n is a constant number. N is a number of the particles which is constant in the system. Therefore the first derivative of capital N will be 0. So the first term is 0, and now come to the second term. So for the second term it will be n1 into 1 upon n1 into delta n1 माइनस डेल्टा n1. इसको दो बार में लिखेंगे, नहीं एक टर्म हमने यहाँ पे नहीं लिखा है, एक टर्म यहाँ पे अभी और आएगा, इसको कट करते हैं, इसको दोबारा से लिखिए. माइनस फर्स्ट n1 log 1 का लेंगे तो n1 इंटू डेरिवेटिव ऑफ log 1 विच इज़ 1 अपॉन n1 इंटू डेल्टा n1, एंड देन प्लस log n1 into delta n1, and then minus delta n1. And similarly we have to write for the second case. n2 वाले के लिए भी इसी तरह से लिखेंगे, और फिर n3 सबके लिए इसी तरह से लिखेंगे. So if we collect all these things, then what will be? It will look like minus summation over I into delta ni. It will get cancelled, and here it will be 1 plus log n1 into delta n1. यहाँ पे एक स्टेप आप ऐसे लिख सकते हैं, ये कैंसिल हो जाएगा, and if we take delta n1 common, then it will be 1 plus log n1. So और ये delta n1 अलग ही रहेगा. So if we collect all these terms, then it will be minus summation over I delta ni, and then minus summation over I log ni delta ni, and then that will be equal to 0. That will be equal to 0 for the most probable condition, that which is this condition, or this can also be written as is equal to summation over 1 plus log ni into delta ni is equal to 0. So this is the condition. That is summation over I 1 plus log ni delta ni is equal to 0. This is the condition for the most probable probability or most probable macrostates. So now one more topic is left, so move towards that, and the topic, last topic of today, that is the constants and accessible states. Constants and accessible states. And accessible states. So in any system, whenever there is distribution of the particles, we may have some constants. Constants means the restrictions. So suppose we have the system having n particles with the total energy capital E. E is the total energy of the system. Total energy of the system. And we want to distribute n particles into cells with numbers n1, n2, n3 and so on. So what are the constants? The constants are that n1 plus n2 plus n3 and so on. That should be equal to capital N. We cannot avoid this. We cannot violate this. ऐसा नहीं हो सकता है कि कुछ particles को हम छोड़ दें. If we have the n particles, then we have to distribute all these n particles into n1, n2 and n3. Therefore, n1 plus n2 plus n3 should be equal to capital N, the total number of the particles. And this can also be written like summation over ni, summation over I. So this is the first constant. And the second constant is that suppose small ei is the energy for the ith cell, then small ei ni plus, इसको 1 कर दीजिए, ei तो समेशन में लिखेंगे e1 n1 and then e2 n2 plus e3 n3 and so on. So this must be equal to total energy. So because total energy E and that energy will remain constant. Total energy of the system will remain constant. So we have to divide this total energy among different cells as E1 N1, E2 N2, E3 N3. And in the summation form, this can be written as summation over I, EI, NI. And that should be equal to, here it is capital N and here this is equal to total energy. So these are the two constants. This is the first constant and that is the second constant. And then accessible states. So accessible states are defined as those states, accessible states are those states which are allowed under given constant. Suppose we distribute the particles such that n1 plus n2 plus n3 is not equal to capital N. So such type of distribution or such type of the state is not possible. So this is not allowed. Or if we have the energy such that E1 N1 plus E2 N2 plus E3 N3, this is not equal to capital E, and if this is more than E or less than E, then such state is also not allowed. So the only states which are allowed or which are accessible, only those states which follow these constants also. So those states are the accessible states, and the states which do not are the states which violate the constant, then those states are the not allowed or unaccessible states. So this is all about today lecture. Now if someone has any query, you can ask. अगर कोई क्वेरी है तो बताइए, माइक खोल के. अगर नहीं है तो भी बताइए, और अगर है तो भी बताइए. किसी को कहीं कोई कंफ्यूजन है, कुछ पूछना है? शायद नहीं पूछना है. तो एक मैं इसमें आपको एक क्वेश्चन दे देती